Alright guys, in this video we're going to discuss a pre-laboratory assignment for an experiment titled Colorimetric Determination of Aspirin in Commercial Preparations. This pre-lab is going to be due before you come to class to complete this experiment. You will not be allowed to work in the lab unless you have the pre-lab submitted on Canvas. And I wanted to shoot this quick video to explain to you what you need to have done and what is supposed to be submitted. In this pre-lab, besides the pre-lab itself, you will also have to upload an Excel file containing a calibration graph of absorbance versus concentration of glucose. So we're looking at question 3 on page 65, that's your pre-lab. In question 3, it talks about determination of glucose concentration in blood serum based on formation of blue-green complex of glucose and a substance called orthotoluidine. It says this reaction is shown at the bottom of the page. It's actually on the back of the page, very last thing on page 66, the chemical equation. Then it talks about analytical wavelength. That's irrelevant to this pre-lab. And we're not going to talk about it with regards to the pre-lab. It's going to be in lab that we'll discuss it. And then it says a set of standard solutions was prepared by taking a known volume of a stock glucose solution containing 1 gram of glucose dissolved in 100 milliliters of distilled water and diluting to 100 milliliters with distilled water. So this sentence is not worded very well, so I just wanted to sort of unpack it for you. And the first thing we'll look at is stock solution. And as you can see, there is a data table in the question, and then part 1 of question 3 says calculate molar concentration of glucose in the stock. So that's the first thing we're going to think about. Stock glucose solution is made using exactly 1.000 grams of glucose, and it's dissolved in 100 milliliters of water. Didn't do a very good job putting decimal here. I want to make sure you see the decimal. So the first part of this pre-lab is to calculate molar concentration or molarity of the stock. What you're going to do is take 1 gram, you're going to convert it to moles. You obviously need molar mass of glucose, and then a chemical equation on page 66 provides the chemical formulas, structural formula for glucose. So make sure to add up all the carbons, hydrogens, and oxygens carefully together, and that will give you the molar mass of glucose, and then you can use that molar mass to find moles. And then finally, to find molar concentration of glucose in the stock, you're going to take moles of glucose and you're going to divide by 0.1 liters, and that will give you molarity of the stock. And then, that stock is used to make standards. Standard solutions are prepared by taking a portion of the stock and further diluting with water to 100 milliliters. As you will see in the table, in this page here, there's a total of 5 standards, and for the first standard 5 milliliters of stock is being used, for the second standard 10 milliliters of stock is being used, and so on. And then you have to fill out the second column that says concentration of glucose complex, and what you're given here is percent transmittances. What you're going to do is find equation 4 in background information and use these percent transmittances to calculate absorbance values for all of these standards. You'll also notice that the last entry here is unknown solution. Unknown meaning its concentration is not known, but its transmittance is. And so you can find the absorbance of the unknown. The ultimate goal is to, of course, find concentration of unknown, and we'll talk about this shortly. First, though, standards. How do we find molar concentration of each standard? I'm using solution 1 as an example. The amount of stock or volume of stock being used to make first standard is 5 milliliters. And you need to use dilution formula, which hopefully is familiar to you from Chem 1240. Reminder, dilution formula M1V1 equals M2V2, where M1 and V1 are molarity and volume of solution before it's diluted, and M2 and V2 are molarity and volume of a solution after dilution. In this instance, we need to solve for M2 because we're finding final molarity of the standard, and M2 can be found as M1V1 over V2. M1 here is going to be molarity of stock found previously. V1 will be 5 milliliters and V2 will be 100 because the solution is diluted to 100. Notice I'm using volumes here in milliliters because milliliters cancel, so you don't have to convert to liters. And if you do convert to liters, make sure you convert both, but it's not necessary. So then I'm going to calculate M2 for each of the standards given in the table. Remember, each time M1 is going to be the same for all of them because each time the same stock solution is being diluted, and V2 is going to be the same because every time 100 milliliters of standard is being made. The only thing that will be varying is your V1 value. So once you have all your concentrations of the standards and you calculated absorbances from percent transmittance values using equation 4, you're ready to make calibration graph. Calibration graph, as I already mentioned, must be made in Microsoft Excel. You should make a scatter plot, and then you should get linear trend line. For Beer's law, we typically set y-intercept to 0, and you also need to get the computer to give you equation of the line. Make sure axes are labeled and graph has a title. Typically in science, we label graphs as dependent variable versus independent variable. So whatever is on Y versus whatever is on X. In our case, absorbance is going to be on Y, and concentration of glucose in moles per liter is going to be on X. So make sure to label the axis properly. Remember, absorbance is not something that has units. Absorbance is unitless. And for this particular graph, the appropriate title would be absorbance versus concentration of glucose. And so once you get the equation of the line, it will be something like Y and then some coefficient X. This coefficient here is, of course, equal to the slope, as we'll discuss later for the Prelab discussion. Importantly, here you will have, this is your absorbance, and this is your concentration. So to find concentration of the unknown, you're going to take absorbance of the unknown, and you're going to divide it by K, which is given in your graph's equation. Make sure to show all work as to how you find concentration of the unknown using its absorbance and slope of the graph. That's it.